Humans have been using mathematical concepts in making visual works since the early civilizations, and they've never really stopped. From ancient temples to modern buildings, and from old paintings to modern computer graphics, math is everywhere. Literally. Something else we see everywhere, especially in the recent years, are these black and white little boxes that promise forms, menus, references, and other extra information if we just give them a scan. Behold the QR code, a mathematically run wonder that makes your data one scan away. So, what exactly is a QR code? Well, a quick response code, or QR code for short, is a two-dimensional barcode that can be scanned by devices with built-in cameras. It was created from the foundational idea that a grid system would be capable of storing more information than a barcode, especially because it can be read from multiple directions, angles, and distances. It's named for the fact that the scanning takes only a couple of seconds, bringing the information to your screen in practically an instant. QR codes were invented in 1994 by the Japanese automotive company Denso Wave. Production was slowed because of the limited storage and single scanning direction of barcodes. This problem was solved by an employee named Masahiro Hara, who got the idea for the grid system of QR codes from playing the board game Go. At first, Denso Wave released the technology to the public and sold the needed QR code scanners. However, smartphones with QR code scanners in them appeared in 2002 and soon became commonplace. The pandemic and its contactless culture skyrocketed the QR code into popularity, and it remains widespread to this day. Looking at the QR code, it seems like just a mess of black and white squares, but it actually has a distinct layout that helps it function as intended. Let's start with the main formatting structures. First up are the position markers. These are the three recognizable squares on the corners of a QR code, each made up of an outer eye and an inner eye. When scanning, these markers orient the QR code so that it can be read from any angle. Next is the alignment marker, which is the smaller fourth square with a dot in its center. It serves as the focus point of a scanner and an extra way to orient the QR code when position markers are blurry. These, however, are not present in smaller types of QR codes. The third are the timing patterns. These are single lines of alternating black and white pixels that run between position markers. They help scanners determine the location of the markers and the size of the QR code. The fourth and final formatting structure is the quiet zone, which is the clear space surrounding the QR code. This is important as it separates the QR code from whatever may be present in its surroundings. The rest of what you see in QR codes makes up the actual data read by the scanners. These are also classified into distinct parts, but before that, let's first get acquainted with the term data module, as we will be using this a lot from here on out. Data modules are just the black and white pixels in a QR code. They are the smallest elements present, and they comprise the data storage parts we are about to discuss. The first part read by a scanner is the mode indicator, which is the four data modules forming a square on the bottommost right corner of the QR code. It reveals the data type of the rest of the encoded data, whether they are numeric, alphanumeric, byte, or kanji. Following this is the character count indicator, which is made up of 8 data modules forming a 2x4 rectangle above the mode indicator. This one reveals the length of data stored. These indicators are then followed by the standard data modules, which make up the meat of the code. Next is the end indicator, which is also 4 data modules forming a square. It signifies the end of the stored data. Last are the error correction modules, which constitute the rest of the QR code. They help with determining the original data even if the code has some parts missing. There are usually up to 4 levels: level L or low, which can restore about 7% of code words, M or medium, which can restore about 15%, Q or quartile, which can restore about 25%, and H or high, which can restore about 30%. Considering how widespread QR codes have become, it is unsurprising that many types of them have been created in order to better suit specific needs. Today we'll go over the 6 main QR code format types, but we'll be focusing on the most recognizable, the second one. The first is the original, the QR code Model 1. It's not as widely used anymore as its storage capacity is relatively small and it lacks alignment patterns. The second type is the new and improved version of the first, and it is called the QR Code Model 2. It is likely the format you see in your day-to-day life, as it is currently the most commonly used one. Characterized by a larger storage capacity capable of up to 7,089 numerals, alignment patterns, and 4 levels of error correction, anyone can easily see why it is universally favored. The other 4 formats are the micro QR code, which is tiny, the rectangular micro QR code, which is also tiny but rectangular, the secret function equipped QR code, which contains hidden encrypted data, and the frame QR code, which leaves an area in the center for design. So how does something like a URL turn into a scannable grid-like picture? Well, numeric and alphanumeric characters, bytes, and kanji are first converted into binary code consisting of ones and zeros. These ones and zeros then form the collection of black and white squares that we now recognize as part of the QR code. Each 1 leads to a black pixel, while each 0 leads to a white pixel. The resulting image then becomes a code containing information. QR codes also make use of masking in order for them to be more easily readable. Masking just means switching the colors of data modules. A black one would be turned white, while a white one would be turned black. There are 8 masking patterns that can be applied to QR codes, and they can be expressed in terms of modular equations. For example, mask pattern 0 masks every row and column wherein mod 2 equals 0, or basically every even-numbered row and column. Honestly, error correction is its own journey. But for now, all you have to know is that for QR codes, redundant information is added into the data using a Reed-Solomon error correction algorithm. This redundant information allows the QR code reader to reconstruct the original data even if parts of the code are unreadable. Did you know that a single set of data can actually produce multiple different QR codes? First, different generators may encode identical data into different kinds of internal expression: byte or binary, numeric, alphanumeric, and kanji. Second, whether your QR code is set to the low, medium, quartile, or high error correction level also affects the final product. Finally, a different QR code can be generated for QR code versions 1 to 40, with a higher number signifying more storage capacity. That is if the data is small enough to be stored in each one. Going by this, at most 640 QR codes can be generated for a single set of data. Speaking of generatable QR codes, how many unique QR code combinations are there? Will we ever run out? Well, a version 1 QR code with low error correction alone can store 152 data bits. This will create 2 raised to 152 QR codes. And we're not even going to say that entire figure. How much more for different internal expressions, correction levels, and versions? You can probably spend the rest of your life generating QR codes and still have plenty of combinations left over. But how does the scanning process work? Upon proper positioning above the code, the scanner recognizes the position markers, which allow it to locate where exactly the QR code is. It then begins reading the mode indicator and learns whether the data being decoded is in numeric, alphanumeric, byte, or kanji form. The scanner then proceeds up and encounters the character count indicator, where it learns how many characters the total data is. Then, the scanner proceeds with decoding the standard data modules with the actual data, following a zigzag path up and down until an end indicator is reached. Finally, the scanner goes through the error correction modules. To this day, QR codes are used for a wide array of reasons by a wide array of people. From big and small businesses to recruiting orgs and student groups with fundraisers, QR codes are everywhere. And they're definitely here to stay. So the next time you generate a QR code for the references document of your next school poster, we hope you'll appreciate the intricate mathematics behind that tiny little square.